So with compound volume, the thing that we're looking to do is basically take the volume of each individual three-dimensional figure and then add it to whatever other three-dimensional figures we might have within our picture. So let's take a look at this top left-hand side. It asks us to find the volume of the compound figure. We know that the height here is 9, and that's going to be helpful because that is going to be the height of our base. We have a triangular prism here, okay? So my base is going to be 12. My height of the prism is going to be 9. And then we also have this distance right here is going to be the same as this distance, which is 4. That's going to be my height of the triangular prism. And then, of course, down on the bottom, we've got our rectangular prism with a base of 16 times 4 and then a height of 6. So all we're doing here is we're going to take each individual volume and then add them up. So let's start with our triangular prism. Volume of, and I'm going to call it a triangle because we got two prisms. One's a triangle and then one is a rectangle. And so because they're prisms, it's just going to be base times height. Same thing for our, and I'll go on ahead and make this in red. Our rectangular prism is going to be also base times height. However, getting to those bases is going to be a little bit different. For our triangular prism, we've got 1/2 times base times height of our triangle, and then we're going to multiply that by the height of our prism, which is 4. And then for my rectangular prism, we've got base times height, or this is going to be base times width times height, length times width times height. So we've got 16 times 4 times 6. So we're just going to be multiplying these out. Here, 12 times 9 is 108. So we've got 1/2 of 108 times 4 equals 1/2 of 432. Divide that by 2, we get 216. And then our rectangular prism, 16 times 4 times 6 equals 384. And so I'm going to combine those. I've got 216 plus 384, and that's going to equal 600. 600 feet cubed. That's all it is. Take each individual piece and then add them together. Nothing too crazy. On this one, and really on the next three, we do have something a little bit different based on the fact that we're dealing with a sphere, but it's not just a sphere, it's actually a hemisphere because this prism covers, or this cylinder covers everything below. So everything below this black top would be considered part of the prism. Everything above is part of the hemisphere. So the way I need to do this, let's take our volume of our prism first because we know how to solve for that right away, or our cylinder, excuse me. Volume of our cylinder. We'll use a brief little abbreviation. Okay, so volume of our cylinder is going to be, again, base times height, but because it's a round base, the area of our base is going to be pi r squared h. So we know that 9 is my radius, which makes 17 my height. So we have 9 squared which is 81 times 17. So we have 1377 pi. I'm going to leave it just like that for right now because I like to leave pi until the very, very end if possible. Let's take a look at our half a sphere. So our volume of a sphere is going to be 4/3 pi r cubed. Okay, so my radius is going to be 9. Now the thing that I'm dealing with here, it's not just sphere, it's a half a sphere. So what I actually want to do, don't want to erase it, what I actually want to do is I want to take this formula and I want to add something to it. I'm going to multiply by 1/2 because I'm not doing the whole sphere, I'm doing half a sphere. So all I need to do here, I take my 1/2, I'm going to deal with that at the end, 4/3 pi r, which is 9 cubed, all over 3. So 9 to the third is going to be 729. 1/2 4 pi times 729 over 3. And then I'm going to do some things to kind of make this easier for myself. 729 divisible by 3 because it is made up of some 9s, which we also know are divisible by 3. 1/2 4 pi times 243. And I actually can make that a little bit bigger because I no longer have to divide by 3. I've already done that. And actually, to back up a little bit, I saw that 4. I know that 4 is divisible by 2. So if I wanted to get rid of that, I can make this 2 because those are going to cancel out, and I'm left with a 2. These are going to cancel out, and I'm left with that 243. So 2 pi times 243, which makes this a little bit more simple, 486 pi. So I'm left with 1377 pi plus 486 pi. And if I wanted to leave my answer in terms of pi, I could do that. Okay, I could add 486 plus 1377, and that would give me 1863 pi inches cubed. That would actually be a completely and totally acceptable answer. However, we're going to work it down a little bit further, okay, and just multiply that by pi. So I'm going to take that, multiply by pi, and I end up with, we got 5852.79 inches cubed. We could round to whatever we needed to. If we want to round a whole number, 5853, tens place 5852.8. We've obviously rounded to the hundredths place. If I was going thousandths place, I would leave it with that 7 at the end. A lot of different ways to round that, but I do want you to show that. Okay. To me, it's a lot easier to save pi for the very, 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 very end, but just treat it like an X until the very end. But if that's not something that jives with you, then make sure that you have a plan to work through it. Okay. Here, we've got another hemisphere. Okay. And we have a cone. If the diameter is 12, then my radius is going to be 6. Okay. Let's go on ahead and do our cone first. So volume of our cone, that's going to be, and I'm going to go on ahead and go with a little bit finer point on my pen. Volume of a cone, that's better. So it's the same. Instead of it being pi r squared h, though, we're going to do pi r squared h all over 3 because we know that 3 cones equals a cylinder. So when I plug all this in, pi r is 6, and then h is 12, all divisible by 3, or all over 3. Okay, as I work this down, 6 squared is going to be 36. So that's pi times 36. And I'm actually going to cancel right here. 12 divided by 3 is 4. So pi times 36 times 4. That's a little bit simpler than having to deal with it all later. I'm just doing 2 different pieces at the same time. I took that 6 squared to get my 36. And then 12 divided by 3 gave me that 4. And I no longer have that 3 in the denominator. 36 times 4 gives me 144 pi. So that's my first part, and I'll hang on to that. Now I have the volume of my half a sphere. So volume of half sphere, that's going to be, again, 1/2 times 4 pi, my radius is 6, cubed over 3, okay? So remember, I did some things at the same time. Let's go 6 to the third power. 6 to the third power gives me 216. I'm going to cancel those right now. Okay, so that's going to equal 2 pi times 216 all over 3. I'm going to go on ahead and divide 216 by 3 to simplify this. So I've got 72, excuse me, I have 2 pi times 72. So 72 times 2 is going to be 144 pi. And now what I have to do is I've got to add these 144 pi's up, or multiply it by 2 to get 288. So if I add both of those pi's up, I get 288 pi centimeters cubed. And if I multiply 288 times pi, I get 904.78 centimeters cubed. Okay. So again, not terribly difficult. We're just doing what we did last class on the last set of slides in finding all these individual three-dimensional figures and then adding them up. The biggest change is that half a sphere. We're just taking the original volume and then dividing it by 2. So here we've got a cylinder and a cone, or a cylinder and a hemisphere, excuse me. So volume of my cylinder is going to be base times height, pi r 3 squared times the height, which is 8. So 3 squared is 9. 9 pi times 8. 9 times 8 is 72. So we've got our 72 pi to start off with. And then my hemisphere, that's going to be 1/2 times 4 pi 3, not squared, cubed, over 3. So we end up with, that's going to be 2. So we've got 2 pi 3 to the third power is going to be 27 over 3. And then we end up with 27 divided by 3 is 9. So 2 pi times 9. So we end up with 18 pi. 18 plus 72, when I add those up, gives us 90 pi, and that would be feet cubed. Or if I multiply by pi, I end up with 282.74 feet cubed.